Okay, in this problem, we're asked to find the vertex points and foci for a hyperbola. Okay, we're told it's a hyperbola, but we can also identify it because there's a y squared term minus the x squared term. Anytime we have a minus here, you're going to have yourself a hyperbola. So our general form that we're trying to make it look like is, in this case, it looks like y is positive, so let's make it y minus k squared over a squared minus x minus h squared over b squared equals 1. Okay, now I'm just writing y squared minus x squared because that's what it's given to me here. It might turn out to be x squared minus y squared if we get a negative number over here, but let's just wait and see. But because y squared is positive, chances are it's going to be opening up and down. So if it's y squared minus x squared, it opens along the y-axis. And if your equation is the x squared minus the y squared, it opens sideways parallel to the x-axis. Okay, it makes pretty good sense. So we're going to do this by completing the square. So we get our y stuff together, 9y squared plus 36y. And we get our x stuff together, minus x squared minus 8x, and we move our number over to the other side. So I notice there's a 9 in front of my y squared, and I don't really want to complete the square with that, so I factor out a 9 from both of my terms, and then I add my box. Okay, I factor out the negative from my x terms. That's an x squared plus 8x plus a box. And that equals 16 over here on this side. And I have to add in my blue square box and my purple square box. I hope I haven't ran off my recorded page. So what goes in the box? That's the main question. We always divide this number by 2 and we square it. So 4 divided by 2 is 2. 2 squared is 4. But in order to put it over here on this side, I also have to multiply it by 9. So this is a 4 times 9, which is a 36 that goes in the box here. No, thank you. So likewise, we divide this one by 2, and we square it. 8 divided by 2 is 4. 4 squared is 16. But I have to multiply it by my negative out here before I change it to this side. This is actually going to become a negative 16 when I add it to the right side. So now that my y term is a perfect square trinomial, I can factor it to y plus 2. And now that my x's are a perfect square trinomial, I can factor it to x plus 4. And on the right side, negative or positive 16 plus 36 minus 16 is just 36. The 16s cancel. So because I want it to equal 1, I'm going to divide both sides by 36. So we're dividing everything by 36. Which gives me a final equation of y plus 2 squared over 4. So 9 and 36 reduce here. X plus 4 squared over 36. And that equals 1. So there's your general form, or rather standard form, for your hyperbola, if that was your given equation. So now I'm going to erase all of my wonderful work again, over here so that I can do a quick sketch. There we go. So I have a center at -4, -2. So the x term always comes from your x parentheses, and the y term comes from your y parentheses, not first z's, second z's, but x z's, y z's. So -4, -2 means I go 4 left and 2 down, and that's where my center is going to be. So now because it's a hyperbola, I have to make a box, and in the y direction I go 2 units. 2 units in the y direction. And in the x direction, I go 6 units, which is the square root of 36. 1, 2, 3, 5, 6. Oops, I'm off. 1, 2, 3, 4, 5, 6. Okay, and this helps me to make my box. I put a box around here. Now, if this were an ellipse, the ellipse would fit completely in the box. Because it's not an ellipse, I have to do some other stuff. So now we need to put in your asymptote lines. Okay, and they go through your corners. So we extended out this side as well. That's about the least straight thing I've ever done. So these are your asymptotes. Let's see. So because it's y squared minus x squared, it's going to open up and down, and this is one of my vertices. So when it says find the points for your vertex, this point here is 1, 2, 3, -4, 0. Okay, that's one of my vertex points. And this point down here looks like -4, -4. So those would be the 2 points for your vertices as your hyperbola opens up very flatly to approach both of your asymptotes. So here we have a quite flat hyperbola, like that. And then the last thing you need to do is put in your foci. So your foci for a hyperbola are found by adding your 2 denominators together and square rooting them, which is the square root of 40, which is about 6.4. So from the center, we go 1, 2, 3, 4, 5, 6.4 units away. And from the center, 1, 2, 3, 4, 5, 6.4 units away. So -1, 2, 3, 4, 1, 2, 3, 4. That would be a point of one of your vertices. And then this one down here would be even farther away. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10.4. So for a hyperbola, your foci are always found by adding your denominators together and taking the square root. Okay, the farther the foci are away, the wider your ellipse will be.